Today's objective is to explain how layers of protocols allow the internet to function. Today is a putting it all together day. We've talked a lot about different types of protocols, IP, TCP, DNS, and HTTP. So we're just going to try to bridge the gap and connect all of these in your mind today. When I think of TCP, I always think of transmission control packets because TCP is the thing that's all about packets. But the truth is P stands for protocol, just like the P in many of these acronyms. IP is just, a destination and an origination address. TCP and IP, you often see them together, but don't forget that there's a difference there, just like with HTTP. So internet protocols define how computers talk to one another on the internet. Most of the conversations are conducted in ASCII text, which can easily be read by humans. Thanks to the power of abstraction, and remember that word is similar to layers, so thanks to layers that we don't necessarily need all the details about, we can rely on TCP IP and the multiple layers of the physical internet, so the actual physical part of the internet, to handle the details of actually sending these messages. So when we're talking physical, we're talking like copper wires, fiber optics, Wi-Fi or radio signals. That's what we mean when we talk about the physical layer. HTTP is one such protocol and defines how your browser asks a remote server for the text, images, audio, and formatting information used to render a complete web page. So HTTP is one of the higher up ones in terms of it's working with your browser for the sake of the internet. Think, write, share, break apart each one here that I just explained to you. What does TCP IP do and what does HTTP do? Just remember, abstraction is simply reducing information and detail to focus on the essential characteristics. So you have lots of abstractions in life. If I asked you how you're doing today and you just say good, technically that's an abstraction. That might not be 100% true. There may have been a bad part of your day, but overall, if you're saying it's good, there's so many details that lead to that answer of you saying good, but I don't necessarily need to know all those details to believe you that it's a good day. Server. A server is a computer that awaits and responds to requests for data. So that's the type of computer it is, simply a waiting machine. And then when you say the word client, you mean this is the type of computer that is requesting the data from a server. So there you go with the picture for you visual learners. Client and servers work together. HTTP, like DNS, is an ASCII-based text protocol. It's just two computers sending text messages to each other. What makes it a protocol are the rules of the conversation the two machines are having. In the case of HTTP, it is a call and response protocol for a client-server relationship, where a client requests a web page or other content, such as images or sounds or whatever, from a server. The server looks for it and sends it back. Think, write, share, compare and contrast DNS with HTTP. So HTTP is a high-level protocol that sits on top of all the other protocols and the internet systems we've learned about in this course. That text message conversation between the computers is being broken up into TCP IP packets, and all the data gets sent as bits over wires and airwaves, taking different paths, and it gets interpreted, reassembled at the end. Think, write, share, what device is sending the data through the paths? I'll give you a hint here. Think back to the physical layer that I was just talking about. So here's HTTP in the context of the web. If you're in my web design class, you're well on your way to understanding HTML and CSS. Soon we'll be talking about JavaScript. But these are the markup language that you're using to create web pages, and HTTP here is the protocol that we're using to get those web pages from one place to the other. You'll see at the bottom here we have TCP and IP. Those should be familiar to you, as well as DNS right there, but maybe UDP and TOS are something new for you to see here. Based on this picture, I want you to answer, what do you think a cookie is? So it says step 1, the browser requests a web page. So you're sitting at your computer at home or in the class, and you open up a browser such as Firefox or Chrome, and you request a web page by typing in that web page. That information goes to a server, and the server sends back the page and the cookie. And then for a third step, the browser requests another page from the server. Maybe you click on one of the tabs at the top of the navigation bar, and then it's going to bring back another page, but the cookie's still there. What do you think the cookie could be? If you want to know much more about HTTP than I have time to teach you right now, you can read this article. That would be a good jumping off point. You can read about the differences between HTTP and something called WebSocket, and let me know what you find out. So in summary, we often talk about how the internet works in layers, and this is a perfect example of abstraction on the internet, as one layer makes use of the functionality of abstraction on the internet. In summary, we often talk about how the internet works in layers, and this is a perfect example of abstraction on the internet, as one layer makes use of the functionality provided by the layer below it, without worrying about the details of this functionality's achievement. So you can think to yourself, how many abstraction layers do I actually understand? Do you understand TCP/IP? Are you understanding HTTP? Are you understanding HTML and CSS? The network software and devices on yours and other computers handles looking up addresses, breaking down data, packaging, routing, transmission, and interpretation and reassembly. So it's really quite amazing how all of that stuff works together. So explain how layers of protocols allow the internet to function, and use 3 specific protocols in your explanation.